So 2024 is right around the corner. In this video, I want to talk about the technologies you should learn if you want to become a software engineer in the next 1 year. We'll start from the very basics and understand how you can learn full stack development. Slowly, we will move into some niche technologies, and by the end of the video, you should have a complete roadmap of what to learn. If you want to know how to learn them, we will create videos on this channel. Let me know which is the most interesting technology here that's not available on YouTube. I'm happy to bring a video on that on YouTube for free. With that, let's get into it. So the first thing I keep talking about again and again is if you want to get into development, you need to know the MERN stack very well. This is very repeated advice, but step one always is learning the MERN stack, which is how you can create websites with Node.js as the backend and React as the frontend. I'm going to talk about a few technologies here and create a very high level roadmap. The first thing you need to learn is JavaScript, more specifically the asynchronous nature of JavaScript, how JavaScript runs. It's one of the simplest languages to learn because of a few properties of it being loosely typed and single threaded. Learn about JavaScript, solve a few lead code problems in it, understand these three buzzwords. After that, learn about backend. What is a backend? Why is it needed? And start creating HTTP servers in Express. Once you've done this, understand about databases. The two popular database technologies, either NoSQL databases or SQL databases. These are the more popular ones. By this point, you understand backend, you understand JavaScript, you understand how you can create backends in JavaScript. Then comes front-end development. This includes React and state management. In state management, either recoil or redux. This is the point where you can create simple websites in JavaScript using Express as your backend server and front-end very basic React. After you know this is a checkpoint number 1 right here, where you can create websites, and this is good for hackathon projects. This is good for creating a website for a friend, for a brother for free. This is not good for getting paid. If you want to get paid is when some slightly more tricky technologies will come. So number 1 thing you need to learn after this is TypeScript. Understand why you need it, what is the syntax, what are types, and what type safety means, why this is very useful and used everywhere if you're creating a professional project and not a kiddie project. Now I'm going to write a few things, a bunch of technologies. You should Google, you should ChatGPT and understand what they are. This is the basic way to create a website. If you want to go more advanced, you need to not learn all of these things, but in various projects, one or the other of these technologies might be used. gRPC, tRPC, Open API, Spec. This is not OpenAI, this is OpenAPI, it's a different thing. Dockerisation, AWS for deployment, ORMs, Git, GitHub. The first three, or maybe one more thing, GraphQL. The first three things and GraphQL are just a different way for a front end to talk to your backend. Containerization is a popular way to deploy applications, keep them containerized. Again, happy to make a detailed video. This is the video that wins in the comments. AWS is a cloud provider, specifically stands for Amazon Web Services, which is where you deploy your website so other people can use it. ORMs are a layer that let you interact with your databases. So if this is your backend server and this is your SQL server, ORMs sort of make it very easy for you to be able to interact with an SQL server without understanding SQL queries and what they are and how they're written. GitHub is, I think most of you know it, it's the way to do version control systems in most organizations. Lastly, I want to talk about the Vercel stack, which means React is good but slowly losing popularity, and Next.js is becoming the popular front-end framework. So maybe, not maybe, definitely learn Next.js after you're at this point. And another framework which was not created at Next.js, but someone created it and the company got acquired by Vercel, is a framework called Turbo, which lets you create a very big full stack application. Things are fairly simple here, where you have a simple front end and a back end. Turbo is used for organizations / code bases which have a very big 10 developers, a lot of code bases, a lot of modules talking to each other. This probably is another checkpoint here where you can call yourself slightly advanced full stack backend developer, a MERN stack developer that can actually charge for projects and not one who's creating kiddie projects. At this point is where I would, 1, create a lot of projects. 2, checkpoint my knowledge with open source code bases. These 2 points are super important. I've talked about tutorial hell a lot. You will read about these technologies online, you will see other people create tutorials, but until you create projects of your own, you are not learning anything. And even if you create projects of your own, you're doing things yourself the way you think is the right way of doing it. A lot of times in companies that will actually pay you, this is not the right way to do it. So look at open source projects, look at how companies are actually doing it, make sure you're able to read through their code bases, and only then can you call yourself a full stack engineer who can get hired at one of these companies. It's very easy to do this. It's mildly complicated to do this because of the number of technologies to cover. This is the most difficult part, being accountable, creating projects yourself and learning things. Very easy to look at tutorials of other people coding, very hard to code yourself. So find some motivation here, find some project that you actually like doing, and then build it using some of these technologies. First start here, then go here. Lastly, we'll say this again and again, a lot of open source projects exist. These are real companies that have raised a lot of money. Look at how they've written their code bases. Make sure you're able to understand their code base as long as the code base is written in the MERN stack. This is checkpoint number 1, which is how to learn the MERN stack in 2023. What are the relevant right technologies for you to know to be able to call yourself a good full stack engineer. Next, we will talk about some more advanced stuff, which means after you have done all of these things, you can create projects, you can look at open source companies' code bases, you can crack GSOC, you can maybe crack a remote job in one of these companies. What to do next? Should you stop learning or should you explore more things? So we're going to talk about 2 more technologies after this. Let's get to the first one. All right, so technology number 2 we are going to talk about is DevOps. It's good for you to know DevOps as a full stack engineer, but if you want to be a complete DevOps engineer, which means you want to lead DevOps at a company and take care of how their code base is actually deployed on the cloud, there are 4 technologies that you need to learn. We're going to talk about all 4 of these now. The first one is called Docker/containerization. This is the most important underrated technology that people struggle with after they can write MERN stack code bases. You can write the MERN stack, you can create a website, you can maybe even deploy it without containerizing it. The part where you have to understand, oh, what are Docker containers? Why do you need this thing called a container is where a few people sort of give up. This is where I would urge you to not give up. Understand the importance of containers. This is what differentiates a professional code full stack developer with a Nibba full stack developer. So this is something you need to know irrespective of whether or not you want to be a DevOps engineer. A few technologies I'm going to talk about that you don't need. This you definitely need either way. High level way to learn it is number 1, Dockerize your own full stack app. So until now, hopefully you've created a few applications. Try to containerize it and deploy it on the internet. 2, set up open source code bases locally using Docker. This is where you might understand the power of Docker. This is one of the reasons we learned Docker in our course, which is it's harder to set up open source code bases. An open source code base will have 10 different modules, but most open source code bases will create a single Docker file. You just have to start that Docker file and that will start the front end, the back end, the database, the auxiliary services. So this is a very underrated skill if you want to do open source contributions generally, but even for deploying, you need to know and understand containerization. Step 2. So the next thing we need to talk about is IAC, which is infrastructure as code. If you have not done containerization, the way you might have been deploying your applications until now would be you rent an AWS machine, you go to the AWS console and you click a few buttons, start an AWS machine, you get an AWS machine, you deploy your code base on that machine. This is great, but not great as your application grows for two reasons. One, if you want to go multi-cloud, which means you want to deploy your app not just to AWS, but to DigitalOcean, then you have to press buttons in two places. Number two, if your AWS account gets hacked, if you want to change your AWS account for whatever reasons, a lot of times the reason is the bill here is really high and we don't want to pay. So companies do this, they change their AWS account and don't pay bill on their existing AWS account. The problem there is if you have 20 machines here and you go to a new AWS account, you have to create 20 machines here by clicking a lot of buttons. Infrastructure as code, as the name suggests, lets you describe your infrastructure in the form of code. So basically, you have a file where you describe, okay, I need 20 EC2 instances and these are my AWS credentials. And then you run a specific command that starts 20 EC2 instances on AWS, and similarly you can write the same for DigitalOcean and other clouds. So what is IAC? Infrastructure as code. What does it let you do? Describe your infrastructure in the form of code. You run a single command, you deploy it on one AWS. If your AWS goes down, gets hacked, or if you want to just change AWS to save a bunch of bills, you run the same commands on a different AWS server, you start 20 instances on another AWS server. The most famous technology to do this is called Terraform. And if you do understand Terraform and are able to write Terraform files that let you deploy to AWS, second step where the learning sort of ends is creating your own Terraform provider. What does that mean? AWS, DigitalOcean have created their own providers. You write them in the code base. I need 20 EC2 instances. It starts 20 EC2 instances. You can create your own providers, which may let other people do a bunch of things. So the only thing that's done here is not creating EC2 instances. A Terraform file can describe other things, firewalls, networks, security groups, load balancers, S3, cloud stores, a bunch of these things. So IAC lets you describe a bunch of these things. Let's say you own a cloud of your own. Chalo, cloud thoda zyada ho gaya. You have another service, which could be a dummy service, a hello world service. You should expose that as your own Terraform provider. It's a pretty good thing to know. This is where you can call yourself a step 2 DevOps engineer, where you can understand and create IAC files. If you want to create a provider of your own, you can do that as well. I did this at Goldman. My learning graph was fairly high because I not just used Terraform, I also created providers of my own. With that, let's move to the third one. So point 3 and point 4 are sort of related. Point 3 is Kubernetes. Point 4 is something called Helm. Kubernetes is what's called a container orchestration engine. Too many heavy words together. So let me just break it down. When you have AWS machines out on the world, you deploy your applications there. Usually you rent an AWS machine and you run node index.js. This is not the best way to run a backend server, for example. Why? Because you should always containerize your applications. The problem is, once you have created this thing called the container, a lot of times you want the single container to, let's say, be deployed to 5 different machines and not one. So if I have one AWS machine and another AWS machine, you might want one container C1 to be running here as well as here, C2 to be running here, C3 to be running here, and a bunch of your services to be running in various what are called clusters of Kubernetes, which effectively means EC2 machine 1, EC2 machine 2, running 2 containers, one container here, one container here, one container somewhere else. Kubernetes is a technology that lets you do it. What does it let you do? It lets you describe in a file, or like actually a bunch of files, where you should deploy your containers. It does not let you create containers. Docker is what lets you create containers. This lets you orchestrate containers, which means put containers in various machines. Usually this bunch of machines could be in DigitalOcean, could be in GCP, could be in AWS, is what's called a Kubernetes cluster. Cluster basically means these machines are no different from each other. They are all running Kubernetes, and you tell Kubernetes, bro, run C1 on 2 machines, C2 on 3 machines, and C4 on just a single machine. More specifically, run 2 instances of this, 3 instances of this, and 1 instance of this. Kubernetes does the heavy load of starting these containers. Why is this good for you? Because you just have to change this configuration, run a single command, and Kubernetes, the engine, will take care of deploying them here, killing containers, restarting containers, in case a container dies, restarting it, all that jazz. So what do you need to learn? You need to learn Kubernetes after this if you actually really want to go deep into DevOps. What does it let you do? It lets you do container orchestration, which is like a buzzword. What does it really mean? Lets you put containers on machines by running a few commands. The problem is, this is very hard to do, not very hard to do, this is actually fairly decent, but like as your application grows, it's very hard to keep running this command and keeping track of, acha, this was the command that ran, and then this was the command that ran. This is how we increased and decreased our servers. So Helm is a package manager for Kubernetes, which basically means you can write files in the form of what are called templates and define this is what my Kubernetes configuration looks like, and run a few commands like Helm update that will update a very big Kubernetes cluster of yours with whatever you have described here. It lets you describe all of this in the form of files, which is why it's called a package manager for Kubernetes, similar to how Node, or not Node, NPM or Yarn are package managers for Node. After you've done this, and this is, I mean, there is no end to how much DevOps you can learn, but this is a pretty solid engineer who can, one, containerize other people's applications, their own applications, full stack backend machine learning applications. Two, use infrastructure as code to describe what their infrastructure should look like, how many Kubernetes clusters they need, what machines they need to bring up, what are the firewall rules, which ports are open on what machines. Kubernetes using these containers, which are already there on some what's called Docker registry, which means you take these containers, you put something there. Kubernetes to pull them to a machine and then deploy them in not just one machine, but what's called a cluster. And then finally, Helm to actually manage your Kubernetes cluster and your Kubernetes files. What should the configuration look like in a very nice, what are called templates, which basically means you can describe a bunch of files that describe what your Kubernetes configuration should look like. DevOps, not complete, but a very good DevOps engineer who understands all four of these things. That was number two. Last technology that's good to learn, I would urge you to learn, and I'm learning myself, is writing low latency code. Why is this useful, Harkirat? This is useful for getting that 4 CR offer, understanding how trading firms work, and what are the day-to-day functions of a trading company. Even if you want to create a full stack application, if you want to really reach nirvana, which means your backend application should be really fast, for whatever reason, one, you want to make it fast, two, you have a specific use case where it needs to be fast. For example, the very basic example here is a Zerodha-like system where it is a trading application which a bunch of people are trading on a day-to-day basis. This needs to be really fast, and the execution engine, more specifically here, needs to be really fast. How do you build these? What are the technologies you need to learn, and how you should learn them? What are the buzzwords to keep in mind? Let's get right into it. I would urge you to pick one of 5 languages here: C, C++, Rust, OCaml, Zig, Golang. Which one should we choose, Harkirat? C, C++ is the OG language. It's slightly hard to write low latency code here and do memory management, which is why the other side of the spectrum is Golang, which is much easier to understand and write, and it is pretty powerful. Zerodha, from what I know, their core trading systems have been written in Golang and not any of these fancy technologies. So Golang and C++, if you are a college student, if you're just starting out, are decent technologies. If you want to go one step ahead, I would say Rust. Rust might be slightly better than C++, purely based on how it does memory management and how you don't have to worry about doing garbage collection and the way Rust does it. OCaml I talked about because Jane Street, which is one of the most famous trading companies that pays a lot of money, has most of their code base in OCaml. In fact, at this point, I would like to introduce a YouTube channel called Coding Jesus, which I will also link in the description, where I think this person used to work here, talks a lot about how you can build trading systems. I don't think they write it in OCaml. I think they write it in Java. but for you, the thing you need to understand is logic, how to build a trading system, and not which language it's written in. Zig is the new fancy popular technology. A lot of traders that I talk to are learning this, in fact, building all their systems in this. I have no idea about it. I know Bun, the very famous new Node.js bundler runner runtime is written in Zig, and a bunch of traders that I know are also very big in Zig. So Zig would be the last technology probably to learn here, not if you're on this channel and doing beginner friendly things. What is the beginner friendly path here? Maybe Golang is the easiest. If you want to go step 2, Rust. Iske aage, if you want to go, do go. If you want to ask me for tutorials, you ask me in Rust or in Golang. Maybe in Zig because I'm trying to learn this and I have few people I know now who are good at this. Alrighty, next I want to talk about why this is popular. One, these companies make a lot of money. Why do they make a lot of money and why do they need engineers to write code in these languages? Because these languages are really fast, give you access to memory management, serialization, deserialization of data. And why is that useful? This is useful because every microsecond counts when you're making money via trading. How do you make money via trading? There are a bunch of ways, but at a high level, the way these companies make money is 1, arbitraging, and 2, market making, which are technologies you can learn about. I'm just going to write them here. Arbitraging and market making. And in both of these things, and there are like other ways, of course, for them to make money. These are the 2 popular ones that I know. And in both of these cases, time is of the essence, microseconds matter, which is why each of these trading firms have sort of chosen one of these languages. As I've said again, Golang, Rust, Zig is probably the path I would take on this channel if you're on this channel. Lastly, the other benefit here is, one, you can, of course, build trading systems, build trading bots and make a lot of money. The other is a lot of Web3 frameworks, or more specifically Web3 contracts, can be written in some of these languages. More specifically, C and Rust are 2 languages that you can use to write Solana contracts. So the knowledge that you gain here can be used to write smart contracts specifically in Solana. And generally, if you understand how you can write low-level code, it's useful, well, useful beyond a point. You don't need it for basic website development, but there might be parts of your code bases that use this. Or if you want to get into Web3, again, very popular technology. That's where we end the video. This is the final checkpoint. These are the 3 high-level technologies I would learn. I would go with 1, then 2, then 3. Now I need 2 things. One, which of these technologies do you want me to teach in a single video? So don't be like, teach how to write low latency code in all of these languages. Be like, give me what is needed in Rust, something like that. The most popular comment we will do. And number 2, well, this is not a question, it's more like the next video that this is going to be, of course, on AI. This is one popular technology I haven't yet talked about and is going to be very big in 2024. It's like fairly obvious, but what is this series? I would like to name the series Buzz Words That You Need to Learn That Lead to a High Paying Job. A lot of technologies, well, any technology that I've learned, I haven't been taught. I have heard about it from someone, MERN stack is where you make a lot of money, and then I've learned about it. What I will try to do in this series is just spit out a lot of words that then you can read about Google, about ChatGPT, about, learn amongst yourselves, create a lot of projects and get that final offer. Cool. With that, let's end the video. I'll see you guys in the next one. Bye, 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 bye.